Assalamu alaikum. When we perform an experiment in physics, we use a large number of instruments. The usage of these instruments result in some error. All these errors get added up at the end while calculating the final result. We call this combination of errors as propagation of errors. There are two ways by which the propagation of error occurs. One, by the usage of different kind of instrument, and a second cause of propagation of error is the mathematical operation that we have performed to carry out the final calculation. In this video, we will discuss some of the propagation of errors in the usage of mathematical operation. First, we will start with the errors in the addition of two quantities. Errors in the addition of two quantities. Let's find out. Now here I consider A and B as two quantities which are added together to get the final result. Now first I take a measured value. Measured value of A is found to be A plus or minus delta A. Here delta A represents absolute error involved in the measurement of the quantity A. Okay, and what is this absolute error? Absolute error is nothing but the magnitude of the difference between measured value and the true value. Okay, fine. The next measured value of B. Measured value of B is found to be B plus or minus delta B. Here delta B is the absolute error in the measurement of a quantity B. Then I consider the sum. Consider the sum as Z equals to A plus B. Okay. Now I am going to substitute the absolute error occurred during the measurement of these quantities. Okay, along with them. So Z can be written as Z plus or minus delta Z. This is the maximum possible error in the measurement of Z, which is nothing but A plus B. So A is written as A plus or minus delta A plus B plus or minus delta B. Understand? Now the next step. See, I am going to expand this. What I am going to do so? So write A plus B. Then plus or minus delta A plus or minus delta B. And this is what I get. Now see, look at this carefully. What I do now? These two are taken as such. Now I take out these symbols, plus or minus symbols, common. Now these two are taken common. When I take it common, what I get? I get this delta A plus delta B. Fine. And here A plus B is nothing but Z. From here, this value is mentioned here. Okay. So the next step, Z plus or minus delta Z is the equal to A plus B is nothing but Z. So plus or minus delta A plus delta B. Now I take this term to this side. So what I'll get? I get this Z minus Z plus or minus delta Z, which is found to be equal to delta A plus delta B. And what do we have here in front? Plus or minus. Okay, as you can bracket. So these two get cancelled. Okay, and what remains here is this. Plus or minus delta Z is equal to plus or minus delta A plus delta B. Okay, now both sides we have this symbol, so it can be removed. Okay, the final expression that we obtain is nothing but this: delta Z equals to delta A plus delta B. Okay, I box it for better visibility. Now this clearly shows that the maximum possible error that we obtain when two quantities are added up is equal to the sum of absolute error in the measurement of these individual quantities. Clear? I hope you have understood. Now I will find out the total error, the total possible error in the subtraction of two quantities. Errors in the difference of two quantities. Again, I take A and B as two quantities. Now this time I am going to subtract. I am going to find out the difference between these two. That I'll start with the same steps. Measured value of A, which is found to be equal to A plus or minus delta A. Here delta A is absolute error in the measurement of the quantity A. Okay, then the measured value of B. Measured value of B, which is found to be B plus or minus delta B. Here delta B is the absolute error in the measurement of quantity B. Okay, now consider the sum. Let's consider the sum, or yeah, I'm sorry, consider the difference. Difference to be equal to A minus B, whose value is taken as Z. Okay, here the difference between A and B is taken as Z. Here the sum of A and B is taken as Z here also. Okay, now Z, when we try to calculate Z, here we encounter some error called as absolute error in the measurement of Z, which is included along with it, and the same thing I do with the A and B as well. A is written as A plus or minus delta A minus B plus or minus delta B. Fine. Now I am going to expand this. Look at carefully what method I follow. Here is kept as such. Now each term is multiplied with the minus sign. So minus of B is minus B, and this will become minus, plus will become minus, and minus will become plus on multiplying this with minus sign. So delta B. Okay. Now I rearrange it. See what I do? This is rearranged as A minus B plus or minus delta A minus plus delta B. I take this within a bracket. Then this side, what do we have? Is nothing but Z plus or minus delta Z. Here, if you look at this carefully, you will find that A minus B is nothing but Z. A minus B is nothing but Z. Okay. So the next step, the plus of A minus B, I take a Z. So plus R minus delta A minus plus delta B. Okay. I said Z plus or minus delta Z. Now I am going to take a Z this side. This plus Z will become minus Z by doing so. So Z minus Z plus or minus delta Z equals to, see here what I do. I take this symbol outside, or let me keep it as such. I will increase one more step. Okay, so this time this two get cancelled, this and this get cancelled, and what remains is this plus or minus delta Z equals to plus or minus delta A minus or plus delta B. Understand? Now, see here, whether I write a plus or minus or plus, that is not going to make a big difference. Both are same only. So, I write it this way: delta A plus or minus delta A plus or minus delta B, because both are same. So, this side plus or minus delta Z. Now, I take out this symbol common. So, plus or minus, when taken out as a common, I get delta A plus delta B. Okay. So, these two symbols on both sides disappear. Just disappear. And what we obtained is nothing but this. Delta Z equals to delta A plus delta B. This clearly shows that the maximum possible error in the measurement or in the difference of two quantities is nothing but the absolute error in the difference of these two quantities, which is equal to the sum of absolute errors in the measurement of these individual quantities. Okay, this is what you understand from this final expression. So in both the cases, whether you add or subtract, in both the cases, the total error we encounter is the same. Now, we will calculate the error in the product of two quantities. Error in the product of two quantities. To find the total error involved in the product of two quantities, I take A and B as two quantities. So this time I will multiply them to get the total error involved in the calculation. So here, I follow the same method as I did for other cases. Measured value of A. Measured value of A is taken as A plus or minus delta A. And the measured value of B is taken as B plus or minus delta B. Okay, so here let's consider the product to be equal to Z. I take the product as Z, which is nothing but A multiplied with the B. Okay, now I'm going to expand this. I'm going to write the value of these terms along with the error involved in their measurement. So I start with Z. Z plus or minus delta Z. Here Z is the absolute error in the measurement of delta Z is the absolute error in the measurement of Z. Similar way, A in the place of A, I write A plus or minus delta A, where delta A is the absolute error in the measurement of the quantity A multiplied with this. B plus or minus delta B. Fine. Now, look at carefully what I do. I'm going to multiply each term with the components present within the bracket this way. Fine. And the same thing I will do with this as well. Delta is multiplied with the B, then it is multiplied with the delta B. Let's find out what I get by doing so. A multiplied with B, AB, then A is multiplied with the delta B. So here I have plus or minus, so I will get plus or minus A multiplied with the delta B. Okay, then delta A is multiplied with the B, so I get plus or minus. See how I write this? I write it as B delta A. If I want, I can write it as delta A dot B. But it may be confused with someone as a delta AB. Okay, delta AB is different from B multiplied with delta A. So to show that difference, to avoid confusion, I have written this one as B dot delta A. So even if I write delta AB, it is not a mistake, but it can be confused with the delta AB. So I have avoided it. So now this term is multiplied with this. So what I get? Plus or minus delta A or delta B. Okay. This side I have Z plus or minus delta Z. Now I'll make a small change. I'm going to follow a simple method to simplify this expression. Okay, what is that? Now I am going to divide the terms present in left hand side. The Z and the terms present in right hand side are divided with AB. So by doing so, we'll see what I get. Z plus or minus delta Z is divided by Z is equal to AB plus or minus A dot delta B plus or minus B dot delta A plus or minus delta A dot delta B whole divided by AB. Okay. Now you may ask me that why I have done this. Why the terms present in left hand side is divided by Z and the terms present in the right hand side is divided by AB. Would it make any difference? Here definitely it will not make any difference. The reason is here Z is nothing but the product of A and B. So whether I divide the terms on the right side with the Z or its correspondent value, it's not going to make any difference. I hope you have understood. Now I'm going to expand this. See how I expand it? On expansion, Z divided by Z plus or minus delta Z upon Z. This side, AB divided by AB plus or minus A dot B, A dot delta B divided by AB plus or minus B delta A AB plus or minus delta A dot delta B divided by AB. Okay. Now here this 2 get cancelled and what you get is 1. The same thing happened here as well. This 2 get cancelled and we obtain 1. Here A and A get cancelled. Here B and B get cancelled. Fine. So let's find out what we get in the next step. Here 1 plus or minus delta Z upon Z plus is equal to 1 plus or minus delta B divided by B, then plus or minus delta A divided by A, then plus or minus delta A. Now see what I do. I'm going to expand this part. It is expanded as delta A upon A multiplied with delta B upon B. Okay. If you multiply this two, you will get this part. Now I take this within the bracket for better visibility and for my convenience. Okay. Now look at here carefully. Here delta A is a very small value. It is a fraction of A. The similar way, delta B is also a very small value. It is a fraction of B. When a small value is divided by a large value, we get a very small value as a result. Okay. So here delta A upon A is very small value. In the similar way, delta B upon B. These two are small quantities. Fine. So when we multiply a small quantity with another small value or quantity, we get a result whose value is almost negligible. So this portion is neglected. It is neglected. Let me elaborate this with the help of a simple numerical example. Suppose you have 1. 1 is a small value compared to 10. When 1 is divided by 10, you get a 0.1, very small value. Suppose I increase the value in the denominator 10 times, becomes 100, and the value obtained to me is 0.01. When it is increased further, the value obtained is nothing but 0.01. Okay, as we increase the denominator value, the result obtained is getting smaller. This is obvious from the diagram. I'm sorry, from these values. That is why the fraction of this, the division of delta A and A, is a small value. On multiply this with a small value, again we are going to get a very small value. So it is neglected. Even the presence of this is not going to make any difference in this part of the equation. So it is neglected. So what I obtain here is this. Now before doing so, 1 is taken this side. So plus 1 will become minus 1 when it is taken to the other side of the equation. So 1 minus 1 plus or minus delta Z upon Z equals to plus or minus delta B upon B plus or minus delta A upon A. Okay. This 2 cancel, it becomes 0. What remains is this, plus or minus delta z upon z. This side, I take a plus or minus common. When it is taken common, I obtain delta b upon b plus delta a upon a. Now this can be rearranged. Now let's see, both sides we have plus or minus. You can omit this. Delta z upon z can be written as delta a upon a plus delta b upon b. Okay, and this provides me the final expression. And what does it mean? It shows that the total fractional error on multiplying two quantities is found to be equal to the sum of fractional error in the individual quantities. Okay, this is the fractional error of quantity A, this is the fractional error of quantity B. Now on adding these two, we get a delta z upon z. This is the fractional error in the product of these two quantities. So what is this fractional error? This fractional error is otherwise referred as relative error. It is nothing but the division between absolute error of a quantity with its total value. Okay, when this is the actual value of some quantity, and this is the absolute error which we have encountered on the measurement. This we call, this division is referred as relative error or fractional error. I hope the video is useful. If you have any kind of doubt relevant to the topic, kindly put a question in the comment section. Thanks for watching.